Hello, everyone. Welcome to this live lesson of our training and fine-tuning LLMs course. My name is Darek Kłeczek. I'm a machine learning engineer at Weights and Biases, calling in from Warsaw in Poland. We'd love to learn where you're calling from. If you can say something about you in the chat on our events platform, or if you're watching us on the YouTube live stream, that would be very helpful. I'm super excited to be joined here on the stage by fantastic speakers. We have Wei Yang from Microsoft and Mark Sarufim from Meta, who are co-hosts of Nurip's LLM Efficiency Challenge. And they will tell us more about this challenge today. Super excited to learn more about this. I think this will be very relevant for all of you that are interested in fine-tuning LLMs. And we're also joined by Ayush Thakur, a machine learning engineer at Weights and Biases. And Ayush will give you like a very practical, hands-on help to get started on this competition, including a starter package with the code to get started. So also excited about that. So at the end of this lesson, you should be able to get started fine-tuning your models, which I think is a good start of this course. So why are we excited about training and fine-tuning LLMs? At Weights and Biases, we work with multiple customers, and this is one of the top questions that is always coming up. Everyone seems to be interested in LLMs. People are asking, how do we train, how do we fine-tune these models efficiently? And this experience that we have is also backed by data. What you can see on this chart is the number of archive papers that contain large language model keywords. And you can see it's growing exponentially. And given this exponential growth, like that can mean two things. Either it's a bubble, or it's actually like a groundbreaking technology that is making a lot of new use cases possible. And my personal assessment based on my experience is this is the latter. We can see a lot of new applications being enabled by this technology. Myself personally, I've been using LLMs to assist me with writing, to assist me with coding, to edit articles that I write. I've used LLMs to extract structured data from unstructured documents, a task that would take me weeks before this technology became available, and now something that we can do in a couple of hours. We've been using this for education. I've recently heard one of the people that is behind some of the popular fine-tuned LLMs, the open source LLMs, has learned how to do it from GPT-4, which I think is a huge evidence that these tools are also helpful in education. At Weights and Biases, we've been using LLMs to help with customer support. We have a bot on our Discord server that helps users solve some of the technical problems they might be facing when it comes to Weights and Biases. We've been using it to automate translation of our docs to different languages, making the product also more accessible internationally. So this set of applications makes this feel really exciting, and that brings a lot of people into this field. However, this field is not entirely new. Like for those of you that have been in machine learning, specifically in NLP, we've had language models applied effectively to solve different use cases for a couple of years. Started a couple of years ago with ULMFit that achieved state-of-the-art results on sentiment classifications on IMDb. And then we had a huge explosion of encoder models and specifically transformers with BERT that started to solve a lot of different NLP tasks very successfully. But the focus of this course is going to be on the right-hand side of this evolution tree of LLMs, and that these are the decoder-only models, the autoregressive language models that are trained to predict the next word in the sequence, which started with the GPT family. They became like really powerful. We started scaling them. We've seen success of ChatGPT, GPT-4, and more recently, a lot of commercial models, including Palm and BART and Claude, Cohere Command, as well as open source models. We're all super excited about Llama, but also other open source models like Bloom or OPT. They make a lot of use cases possible. And this is gonna be our focus. This is where we see a lot of benefits from the scale. These models are are able to solve a lot of tasks in a very general way. Given this popularity and given this power and the number of applications of large language models, a lot of you might want to get started with LLMs. And probably the best way to get started with LLMs is by using them via APIs. And you might be familiar with the open APIs provided by OpenAI, provided by Anthropic, provided by Cohere. In fact, we recently released a course that teaches you to use these APIs to solve different business problems and to automate different tasks. So this course might be a good entry point into the world of LLMs. The benefits of using LLMs through APIs is it's easy to get started. You don't need to do any or much of an upfront investment, either in training, in compute, in data, in capability. You can access really well performing large language models very quickly. On the negative side, and whenever you get into production and you get a large volume of requests in production, your inference cost may be substantial. So you need to prepare for that. You may need to share data externally, and for some use cases, for some organizations, that may be something they'd rather avoid. Yeah. So we talked about the cons, like the negative aspects of using LLMs through an API. Another one is lack of flexibility. For example, in many use cases, you may want to implement inference on the edge, and again, that might be hard if you're using these LLMs behind APIs. So if those negatives like outweigh the positives of LLMs, you may want to get into this second part of the solutioning, which is either fine-tuning an open-sourced LLM or pre-training your own LLM. When do you want to fine-tune? If you want to benefit from this external investment that is done by companies that release these open-source LLMs, if you want to take control over the roadmap, if you want to own model weights, that may give you some control over the future of the products that you're building on top of LLMs. It becomes more difficult. You need to get the right skills. You need to do the right investment, and hopefully this course will provide you with some of the skills that are needed to fine-tune or train your own LLMs. Pre-training LLMs is even more expensive than fine-tuning, but there are many use cases where it might be the right choice. You may want to do it for competitive advantage. You may want to have full control over your roadmap, over the future direction, over the training data, but you need to be ready to significantly invest in terms of the talent, in terms of compute resources, and also be prepared to face some risks, because this is not always easy. So what are the types of fine-tuning? The first type of fine-tuning I want to talk about is fine-tuning for specific tasks. And given that we are mainly focusing on autoregressive language models, which are trained to predict the next word in a sequence, if you train a base language model, they will simply learn to continue a given text. But we may want to fine-tune them, to teach them to solve specific tasks. And that thing we can achieve via fine-tuning. One example of this is the T5 model that was trained, where was trained to solve different tasks where the task is defined as some sort of text, and then the answer is a solution to this task. I think some of the tasks that are going to be used for the evaluation of the challenge that we will talk later today may be framed in this way. So it's a good idea to look at this different type of tasks that and the way of phrasing them in text, and a different way of using prompts to then guide the model to solve specific tasks. This can be made very specific. This can be made specific for your application, but there are also more general ways of fine-tuning language models. They have been really made popular by OpenAI, starting with the instruction tuning approach, and then instruction tuning. In the instruction tuning approach, we teach a model to follow instructions. We may not necessarily want it to continue the text that we start with. We may prefer it to give it some instruction and then get a response that follows that instruction in return. And the first step to achieve it is supervised fine-tuning, we provide a model with a set of instructions and responses, and then train a model to behave in a similar way. Another step that is often used on top of instruction fine-tuning and the supervised step is reinforcement learning from human feedback. And that in turn also consists of two steps. One step is training a reward model, where we teach a model what humans prefer, and then we use that reward model to train to fine tune our language model via reinforcement learning to be aligned with human preferences. And we'll do a more deep dive into these techniques in later parts of this course. One thing that I want to share is also this boundary between pre-training and fine-tuning is not always clear. We don't know much about GPT-4 or ChatGPT, but the one thing that was shared by OpenAI is actually these models were trained over a series of steps. ChatGPT started as a code model. It was trained on code to help with programming, and then it was further fine-tuned first to follow instructions. Then it was aligned with human preferences using RLHF. It was then further fine-tuned on chat data. And all of the steps resulted in GPT 3.5, which actually I think since very recently we can also fine-tune. So depending on which step, which type of checkpoint you're using, you might be actually fine-tuning a model that already had been fine-tuned for a different task. Now, if you want to learn how to do this, I think the best way to do it is by starting to build, and especially with the release of some of the very powerful open source language models like Llama from Meta that we were very thankful for. We see a lot of activity, a lot of people take these models, use different types of data sets to fine-tune these open source language models. They fine-tune it on different languages. They fine-tune it on different tasks. Some of them use synthetic data. And this is a process that actually has become possible very recently. And hopefully in this course, we'll also show you how you can do this. And actually for this fine-tuning stage, you don't need that much compute. And this has really become accessible to a broader range of audience. But you do need several things. And this is something that we'll be focusing on in this course. The first step that we recommend to start with is trying to figure out what is your goal for fine-tuning. And to do this, you need to figure out the evaluation. How will you tell that your model is actually progressing and is learning, is improving? For that, you need to decide on an evaluation approach. We'll talk more about evaluation next week. I think the team today will also talk about how they're going to be evaluating solutions in the LLM efficiency challenge. We will not go into the in-depth on the model architecture choices. That is probably a topic for a different course. But once you understand your evaluation, once you understand your business goals and the metrics, you might check different benchmarks, different leaderboards that are available, and pick a foundation model that is suitable for your task. So hopefully understanding evaluation will also help you pick the right foundation model that you may want to fine-tune. And then once you've done it, the hard part is figuring out the right data mix to fine-tune your model on, and then using efficient training and fine-tuning techniques. And this keyword of efficiency is especially important because we're dealing with very large models, and we need to use the right techniques to make them fit on a GPU and train efficiently. And I am super excited that we're partnering with Mosaic ML, and specifically Jonathan Frankel, who is chief scientist at Mosaic ML, who has developed the lessons on data and on efficient training techniques of large language models. And this will be the 2 out of the 4 lessons in this course. So I'm personally excited to be learning from Jonathan. Mosaic ML is training and fine-tuning LLMs as a business and they have huge expertise in this field, and I'm sure everyone can benefit from these lessons. Okay, we have a question from the chat. The question is, what kind of architecture will be used in the course? And actually, we are not prescribing the architecture. I think actually in the later part today, Ayush will provide a comparison of two different architectures, two different foundation models that he used for this task. But we will be focusing primarily on this generative, on the autoregressive decoder-only language models. That's an area that is currently being explored. That's the area that is, I would say, scaling most rapidly into larger sizes. And we also feel like some of the older language models that had like the decoder only architecture, like BERT, the Berta, like the community already knows how to fine tune them. There are good frameworks like Hugging Face, PyTorch Lightning. So we feel like there is a less demand for knowledge on the encoder models than on the decoder only models. Okay, so I think we'll come back to questions later on, but I want to make sure we head over to the hosts of Nurib's LLM Efficiency Challenge. And I'd like to now hand over to Wei Wei Yang and Mark Sarufim, who are co-hosting, organizing this challenge. The reason we are excited about this is we believe the best way to learn is by actually doing, by building. And this challenge provides a way to do it in a very accessible way because they set the constraints that make it available to a broad range of engineers. So over to you, Wei Wei.